Welcome back to Transformations on Functions. We're looking at the graph f of x, and we need to sketch the graph of g of x, where g of x is equal to f of 2x. Notice that since the x is scaled by 2 on the inside of the function, we have a horizontal shrink or compression. Now remember, we're going to take the x coordinate because of the horizontal change, because remember, when you substitute a scalar inside your function, you're affecting the horizontal values. So we just take the 2x, so we can say therefore 2x equals -6, and then solve for x. And x is now equal to -3. So the vertical coordinate has not changed at all. So our new value will be at -3, 4, because our 4 didn't change. That's our y value. Can you tell it's really important to keep track of x comes first, then y for our coordinate points? Now, let's do the same thing for -4. This gives us a coordinate point of x equals -2. So our new coordinate point is -2, 0. Again, 2x equals -2 implies that we get an x equals -1 out. And our new coordinate point will be -1, 4. If you divide both sides of this equation, 2x equals 0, we still get x equals 0. So at 0, you don't get any movement horizontally. We have 2x equals 2, which gives us a solution of x equals 1. New coordinate point is 1, 4. 2x equals 4 gives us x equals 2. So our new coordinate point is 2, 0. And last, we have 2x equals 6. So that gives us x equals 3. So our new coordinate point is 3, 4. Now let's fill in these values, these coordinate points. Our first coordinate point is at -3, 4. Our second coordinate point is at -2, 0. Our third coordinate point is at -1, 4. And our fourth coordinate point is at 0, 0. Our fifth coordinate point is at 1, 4. Our sixth coordinate point is at 2, 0. And our seventh coordinate point is at 3, 4. I'll connect these dots. And you can see how we have not vertically stretched anything. The only thing we've done is compress this like zigzag pattern horizontally. Let's take a look at example 9. Use the graph of f of x to sketch the graph of h of x equals f of 1/2 x. Now hopefully you're recognizing that this one is probably going to stretch or expand horizontally, which is what's going to happen. So we take 1/2 of x, that's the part that's been scaled inside the function, and we set that equal to the horizontal value, which is -6 for the first coordinate point. When we solve for x, we multiply both sides of our equation by 2. If we do that, we get a coordinate point of -12 in the x direction, so we have -12, 4 as our new coordinate point. That one's not even going to fit on the graph. The next one is at 1/2 x equals -4. Multiplying both sides by 2 to clear the fraction, we get x equals -8. And that one will fit on the graph. So our new coordinate point is -8, 0. 1/2 x is equal to negative 2. That gives me a value of x as negative 4. The new coordinate point is negative 4, 4. We have 1/2 x is equal to 0. X is equal to 0. Our new coordinate point is 0, 0. We have 1/2 x is equal to 2. That gives us an x value of 4. So the new coordinate point is 4, 4. For the sixth coordinate point, we have 1/2 x is equal to 4. That gives us x equal to 8. And our coordinate point is 8, 0. And our seventh equation will be 1/2 x is equal to 6, which will give us an x value of 12. And our coordinate point will be 12, 4. If I graph these new coordinate points, the first one and the seventh one are not going to fit on the graph, so I'm going to skip down to the second one. That's at negative 8, 0. So I'm shifting the second coordinate point to the left. The next or third coordinate point is negative 4, 4. The fourth coordinate point is 0, 0. The fifth coordinate point is 4, 4. And the sixth coordinate point is 8, 0. If I connect these dots, we can see that there is a horizontal expansion or stretch. And these would continue off the graph as well out to negative 12, 4 on the left and positive 12, 4 on the right.